The red light's blinking.
So yeah, this thing, I'm gonna take it to work tomorrow.
You don't want to do a test drive without River?
No, we're gonna go all in. Yeah, we'll see if we make it. We'll put the mirrors on it before bed. Whew. All right. To build an 18650 battery pack or to rebuild one, you have to start by tearing out or tearing down the old one. So we've taken our batteries apart. We're starting that process. They come in metal boxes. There's 2 of them on this particular bike. It's called a PEBL bike. And there's about 10 screws on each box. We take those off. We put them in a place that's safe so we can reuse them. And then we just start kind of disconnecting everything. You're going to want to wear full PPE if you do this. And you definitely want to take a video of yourself doing it so you can watch that video later when you put everything back together. So in this case, this is our first part of our battery, and we're taking some voltages. A better way to do this is to measure directly off those BMS leads specifically, and then go into measuring from your series and your parallels after. And we're going to get more into that later, but the key thing is if you're replacing a battery, it's because it doesn't work, and it doesn't work because the battery management system is broken and or the cells are dead. Some of the cells are dead. Maybe some of the cells work. This battery has Anderson connectors connecting the 2 modules together, and when we probe for voltage on those, we can see that our voltage is pretty low. So that's an indicator that these cells are not holding charge and they're not taking charge, which is what we experienced when we tried to charge the bike when we got it. It just won't take a charge. So the battery management system is, in theory, saying, hey, we're not going to take a charge. So then we can start probing the battery at different spots and seeing what our voltage is here. And that's what we're doing here. You can check voltage between each cell group and then document that. At this point, we're going to do some deeper disassembly. So we are going to use a box cutter to cut this tin off the side of the battery, which is connecting one of the leads to the other battery on the positive side. And I'm going to use this strategy to keep disconnecting the leads off both batteries until everything is disconnected, and all that is left that is connected is our voltage cell meter wires that connect to the battery management system. The next thing I'm going to do is I'm going to delicately start cutting off these wires, and each one has its own cell group that can be traced back to a single position on the connector to the BMS. If I had to do this over again, I would have labeled each one of these sequentially and traced the wires sequentially onto the BMS connector. And that's going to make more sense in the future of this video, so make sure you stick around to watch that. This is my first time doing a 18650 battery build / rebuild, so I didn't know what I didn't know. With all my wires disconnected, I can actually lay these batteries out on an insulated surface so they're not going to arc or pass current through a conductive surface. If you don't know what those 2 things are, you definitely want to Google those and figure them out before you start tearing apart your batteries. And that just left me with a little more of this disconnection work on one of the units. And one thing you can kind of see here is that you have groups of cells. Now the ones with the red tops, that's the positive side, and the ones without the red stickers, those are the negative sides. And each one of these is in its own cell group of 24 cells. Let's talk a bit about how batteries work. 18650 battery. The 18650 battery, if you take a measuring tape and you measure one cell across in centimeters, it's going to measure 1.8 centimeters or 18 millimeters. If you measure it long ways, it's going to measure 6.5 centimeters or 65 millimeters. So that's where the size comes from. The core thing, though, that is so fundamental to all batteries is this concept of series and parallel. So if you have your run-of-the-mill battery, there'll be a plus side and a minus side. In red on this paint pen, and the minus side in black with this Sharpie. All right, so here's our first battery. So if I take these two batteries, and let's just assume they're each 1 volt, and I connect these two pieces together, the two negatives and the two positives, so 1 volt plus 1 volt is going to equal 1 volt, because this is a parallel connection, right? But when we do a series connection, we stack them like that, kind of like a flashlight. 1 volt plus, we're calling these 1 volt for modeling's sake, equals 2 volts. And that's your series connection. So let's build on that, right? Let's say you need more than 1 volt, and so you're going to go into series, but you also need a bigger gas tank, right? So you're going to go into parallel too. Well, then you can make a battery that has both a parallel connection and a series connection. So let's look at what that may look like. So here's our example battery. So we have 2 positives and 2 negatives. If we put these together like this, say we stacked them up like that, and we connect these 2 positives to these 2 negatives, we flip it around, do the same thing, we are going to have 2 sets of parallel and 2 sets of series. So this will be a 2 series, 2 parallel battery. We can build on that logic over actual battery packs. So in this case, we have an older battery pack, and the positive connections have a red piece of cardboard insulation on top. The negative connections do not. So we can look at these cell groups. So I have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4 times 6, that's 24. So 24 is our parallel group. And then our series group, here this would be 24P 2C, if we just look at this. But this battery is connected all the way across, right? So this is one connection, and when I got it, it was folded, or when I took it apart, it was folded across like that with a piece of, insulated paper blocking the cells like that. So now let's count this. We have groups of 24 in parallel. So 24P is going to be the same across, right? So now we just count our series. 1, 2, 3, 4, 5, 6. So 24P, 24 parallel, 6 series. That's how we're counting that battery. On this one, we have 1, 2, 3, 4, 5, 6. And then the 7 has been kind of chopped away. So this is before I chopped it away to disconnect the battery management system, this was 7 series 24 parallel. So in each series, we have 24 batteries parallel. We add these together, we have 24 or 13 series 24 parallel. Makes sense, right? Alrighty, so this is our BMS for our battery pack. And we can see that we have a 13 there for our series. The voltage, 3.7 volts, which is your voltage, your nominal voltage of one of these batteries. And then your amperage max, which is 100. Then we have negative conductors here and here. So the positive conductors don't actually hit this board. They stay on the batteries themselves. So there's one there and there is one here. And you can see this one has a little cable here, and this one has a little cable here. Each of these cables are going into this string of cables, and those measure the cell voltage. In this case, the red conductor here and the white conductor here, that's giving us a cell voltage reading of both our packs prospectively. And when they're put together, when you have this negative and this positive, that's the cell voltage of the entire pack. Then all these other little whites are the cell voltage of each battery you have in series. And so those 24 parallel groups that make up each individual series each have one of these connected to it. And this is a passive battery management system, meaning it doesn't have a lot of brain to it. So in simple language, if one of those 24 packs of parallel batteries that's in our 13 series drops voltage relative to the other packs, this thing will stop and your battery won't work. Actively managed packs, these wires can read battery they can read voltage mismatches and manage that so that they can help kind of self-balance the batteries across each other to get those voltages equal again so that the battery works to specification. So that's an actively managed BMS. But your garden variety bike battery board is not going to have a smart BMS. All right, so we are going to rebuild this battery with brand new cells that we got from a website that is called 18650.com. And each one of these is going to be 3.3 volts, have 2.2 amp hours, and that's what it's going to have, right? And we're going to just build this pack the exact same way the other pack was built. These are the old batteries, and we can see that they had probably 2.6 amp hours and maybe 3.43 volts, so maybe a little higher voltage, but maybe that's just the serial number. Don't exactly know. And then to connect these batteries together, we're going to spot weld them. So before we get to spot welding, we want to check and make sure all these batteries have the same voltage. So that one's 3.48. That one's 3.48. That's what we want to see. If we compare that to these, look how low that is. That's 0.31. So that's what I'm going to start by doing. I'm going to check all these battery voltages, and as I check them, I'm going to write my results on my table, or on my battery. So for example, 3.48, 3.48. So now I'm going to do that another 310 times. Make sure all my batteries have the same voltage before I put them together. So this box is all 3.48 volts perfectly at 6:38 p.m. on 05/06/26. Going down, 300 to go. Alright, it is time to insulate our terminals, and we are going with green because that's what shipped fastest on our positive side of our batteries. The old ones, it's red on top, but these are going to be green on top. So that's just the pattern we're going to use, and I'm going to do this 320 more times. With our voltages measured and the tops of our cells double insulated, it's time to start building our modules. So we're going to do 4x6, and we're using some aluminum extrusion at 90-degree angles to help us make our rectangles perfectly rectangular, and then hot glue to glue all our cells together. I did experiment with super glue, and that was a bad idea, so trust me, and I would just say don't do that on your first battery build, and if you do, tread carefully. I ended up gluing this paper to the bottom of the cells and to my work area, and it was such a mess, and it's still not perfectly clean, and I basically had to file the bottom of those cells to get them clean again. It took me 2 modules to learn this, so learn from my mistakes and just use hot glue or something, a glue where you know you're not going to get any glue on the tops or bottoms of your batteries. And of course, I check cell voltage one more time on each cell so that every cell is double checked before I put it in its module. Once I have a module built, I use Kapton tape to hold the cell redundantly in addition to the hot glue. Because we have 13 of these 24 parallels to get together, we're going to repeat these steps 13 times. It's a little tedious, but we take our time, do it right, and eventually we get it done, and then we can connect our conductors together with spot welding. Finally time to spot weld first. I'm going for parallels 4x6, so there's 24 in here. One thing I'll note is that I'm just doing a single layer of spot welding on these cells. I think that's going to be super good enough. And if there was segments that I didn't think were super good enough, I just went ahead and added a second layer just to be super careful and make sure that I had all my connections the way I wanted them. Once that was done, I moved on to the next set of modules. So 2 24Ps making 2 series together, and I just kept making these combinations of 2 until I got through all my batteries, and that's when I started connecting them together into 2 big modules. So once I got the first battery pack all connected together, I'm going to prepare it for being folded in half by using some of this insulation paper. In the battery industry, they call this fish paper. So the next step would be to assemble the second battery and get it all ready to go before putting on our BMS leads that measure cell voltages across the packs within the series, or the cell groups within the series, I should say. But I did this wrong, and I'm showing my incorrectness for just this second so that you can see my learning process. If it's your first battery, it's okay not to get this right your first time. There's a lot to do, and it's just part of the learning process. So the thing to know is you want to build your battery in a way to where you can put your leads on one step at a time as you go along. With just a multimeter, a piece of paper, and some
basic sequencing, you can map out exactly where your voltage balance wires need to go on each cell module. So you can start by measuring from the positive of one end of your battery to the negative of the other end and seeing what your total voltage is. And then you can just start measuring each cell group within each series sequentially and measure those voltages. And it should increase proportionally through each series, assuming your voltages of each cell group are the same, which they should be.
This is our balance wire, so we're just going to start probing from both ends of this, that's 45. So going down 45, 42, 38. So we're going down in our series. 35.
Watch where we go from 31 volts to 24 volts. This is a mistake I didn't catch until the next day. What is happening is that the balance wires have skipped a cell block group, and that's why there's a 2-hop gap in cell voltage. The cell voltage should be proportional within each balance wire. So all those balance wires need to move so that they're all proportional and in perfect sequence from the first part of the series, series 1, to the 13th part of the series, series 13.
All right, so we got the batteries built. We got the BMS connected. The voltmeter says everything's working as it should for a 13 series of 24 parallel 18650 cells, all 312 of them. So we put them in the bike, we connected them, plug in our charger, we got a good link light on our charger. This thing has a voltmeter built in. Come over to this side, and you can see we're getting 40. We have 45.1 volts on our 48 volt battery, which means it's slowly taking charge. So that's a good thing. Over here, we have the back wheel propped up so we can test our throttle. And the motor's working, charge controllers, or the controller that sends power from the battery to the motor's working. Got a horn that's working. Got lights that are working. And oh, there's the lights. Oh, that's an inside light. That's so cool. A little inside light in there. And then blinkers that are working. Here, go back to the back. Show the blinkers working. So yeah, this thing, I'm gonna take it to work tomorrow.
You don't want to do a test drive without River?
No, we're gonna go all in. Yeah, we'll see if we make it. We'll put the mirrors on it before bed. Whew. River, what did you think of the ride to school today?
It was good.
Yeah? How do you like the new bike?
It's pretty good.
Yeah? How did it do on its test drive?
It's pretty good, but what's this pocket for?
Oh, that's the pocket for the IR camera. We just use that to measure temperature of the batteries in the BMS. And this is their voltmeter, which we just use to check voltages across the cell groups. Everything's looking good. Except our voltage is a little low.
How's it a little low?
Can't figure out why it's not charging above 45 volts. Should get a little higher than that. Alright, so we have our new tube, and we are going to get this on like that.
Truth be told, we had quite an epic on the way back from school. 2 miles from the house, this tire was flatter than flat could be, and we ended up getting the e-bike, thinking we could tow this with the e-bike, which completely did not work in any way, shape, or form. So then I took the e-bike home, got the truck, and we ended up towing this bike with the truck at about 5 miles per hour for 2 miles, which took a long time. It was something straight out of entertaining YouTube. I couldn't believe it was real life. So we ordered 3 new 24-inch tires to replace every tire on this bike. The first one was the hardest, and of course I put the tire on backwards, so I took it off and I did it again and put it on not backwards but forwards, the correct orientation the second time around. The front 2 tires went smooth as silk. The other thing that makes the back tires difficult is there are 2 chains, one on each side of the axle. There's a cable for the 8-speed hub gearbox connected to the right side of the hub assembly, and then there's the disc brake. All of that's got to be supported by jack stands while you get this wheel in. Needless to say, you would not want to have to do an on-road repair, but you also wouldn't want to tow this. So hopefully this brand new tire lets this thing run like a champion for a very long time. So the chain tensioner on the motor side for the motor chain was broken on one side, and it looks like it was just poorly JB Weld epoxied to it. I still have that piece of metal, so I figured while I'm in here, I'll go ahead and get the grinder and cut out all this old material so that we can re-weld it in with a new bracket, but we'll use the old one as a spacer. First things first, just cutting away all this old material so that it's ready for new material. One thing that I found pretty neat and interesting about the front wheel hub assemblies was that they have drum brakes. Haven't seen this on a bike before. I think it's pretty cool, and so should you. Alright, enough about tires. I may have brushed over some important details in the battery building process, so let's return to that. What we're going to focus on here is attaching these positive leads to the positive parts of the battery cell so that we have the thing put together perfectly. Now, if you've never done this before and you're taking apart a battery, these big positive leads are going to go in the exact same place the last ones went. And if you're putting on new sheets of tin, make sure you rough them up before you solder. You also may need a high-powered soldering iron. I got a link to the one I used from Amazon in the description below. And if you click on that link, it's an affiliate link. It really helps the channel. Okay, the other thing to note about any soldering is you do not want to do that close to your batteries. So you solder your tin to your wire, and then you spot weld your tin to your battery. You do not solder after the tin's attached to the battery. That was the case when I did my leads, and that was the case when I did the balance wires. If you need to remove the big conductors, in this case I think we have 7 AWG conductors from one of these bigger bus bars, you can use a propane torch to do that, and you could also solder with one of these if you had to. It's not easy, but you can do it. Another tool that's useful is just your garden variety heat gun, and so that's what I'm using here to attach my balance wire to this positive bus bar. And when I said attach, I meant detach, because in this case we're still taking off the old one, and we took the balance wire off first, and then we're doing these 2 leads second. Make sure you're wearing clothing like closed cell shoes. You just want to be in fire resistant clothing so that if any of this molten metal falls to the floor, it doesn't land on any part of your body. And if it were to, you want it to be covered with a protective material that will insulate your body from that molten metal. Particularly things like eyeballs that don't grow back if they're made in contact with molten metal. Okay, so here's our new sheet of tin. This is what we need to get attached to these leads, so that's what we're going to do next. In this case, the heat gun, the flux, the solder, the roughed up surface, all combined together helped us get this job done, but it would have been easier with a high, like 400 watt soldering iron. So high wattage soldering iron would make this job easier. But you use the tools you have until you wait on Amazon and get the tools you need. Another important safety tip is to tape these bus bars when you're not using them, because you do not want them to come in contact with the battery or anything else that could cause a short circuit or heat up the metal. because that could cause a fire and damage your cells or burn down your work area. You're going to have a bad time. So just insulate the metal when it's not attached to what it's going to be permanently attached to, and then insulate the metal when it is attached to what it's going to be permanently attached to. And if it's not permanent, painter's tape and a rubber glove are good non-permanent options. Captain's tape and electrical tape are better permanent options. If you haven't caught on to this already, there's a lot of repeat steps in battery building. So we're just repeating these same steps from the last bus bar to the next bus bar. We're taking off the old metal with the blowtorch or the propane torch, and we're putting on the new metal with the heat gun. We've talked a little bit about the battery management system. One of the very important things about the battery management system is that the leads you attach to the cell blocks are on there securely. And if it's your first time doing this, you want to do it in a way that they can also come undone if you pull them off with pliers. So in this case, we're just using tin, and I'm spot welding.
Thinking a lot about the cell group mappings on this guy, and particularly when it comes to the BMS and how all these voltage sensors connect to each module within the pack and measure its voltage. And how do I know that I'm getting the 13 series wires in the correct sequence? So I'm probably going to have to take these ones off, but starting from the other pack, which connects through this wire, and then these 6 signal wires come out of.
Let's try talking through that one more time.
Okay.
So this is a 13 series pack. So we have 13 signal wires, one for each cell grouping, and they have to be placed perfectly in sequence. So how do you know which wire goes where in the sequence? We can start from the one end of the ribbon connector on the first wire and put the multimeter in tone mode or continuity mode, so it makes a beep when we connect the other side of the probe to the other wire. So you connect the probe on the ribbon cable to wire 1, and then you touch all the wires until you find the wire 1, because it's going to make a tone, and that's your wire 1. Then you go to the next wire 2. Do the same thing. Touch every wire until you find number 2, because it's going to make a tone. Then you document that with some masking tape as number 2. Then you go to number 3. And once you've done all that, you will know which wires on the ribbon cable connector go to their endpoints, their prospective endpoints across the 2 modules within the single pack. So that's what I'm doing here. This step must happen before you attach your leads, otherwise your leads aren't going to be attached in the right location. And after this happens, your leads must be attached in sequence perfectly to each cell block group. And you can check this with your multimeter as you go along. So we're figuring this out through our own guess and check process. And it's going to take us about 4 times of attaching these leads before we get it right. So we only got it wrong 3 times. And if I can get this wrong 3 times, you can probably get it wrong 0 times and just learn from me and get it right the first time. But if you don't beat yourself up. It's just part of the learning to be a battery builder process. In between getting this wrong, I got to practice insulating and uninsulating the battery as I folded it apart, or folded it together like origami to fit into its container. So this is a combination of insulators, mostly fish tape, Captain tape, and electrical tape. So the way you're going to know that you got everything working with the cell voltage wires that connect each series together and connect to the motherboard on your battery management system is that your battery will take charge. The battery management system will not allow your battery to charge unless it's set up correctly. And once it is set up correctly, you can continue to measure the voltage changes in each series within the pack like I'm doing here. And those will follow the same logic. So we start at the end and we are working our way inside with our positive probe So we're going from high to low, and each of these increments is proportional to one another, which is an indicator that our system is working as we are charging our batteries, and everything is running to spec as it should be. And that's super exciting because this is a complicated project. To be honest, I just watched Joshua Bardwell's video on how to make an 18650 pack, and he did like 10 batteries in 2 series, and I started with 24 parallel 13 series. So it was a big uphill. Needless to say, those are good values, and we are good to go, feeling really good about this. While I was charging this battery, I made sure to monitor it with an IR camera just to make sure it wasn't getting too hot anywhere and to look for any shorts in the wiring that I may have missed. Everything looked great, so it charged all the way to the top with no problems. This is gonna be quite an experience, huh, buddy? Lights on. Hi, New Albany. This test drive was so fun, so beautiful. The bike performed perfectly. Loved every minute of it.
I try a little faster than before, I think.
Swerving the road. I said, oh my gosh, because we made it. Voltage range between 45 volts and 41 volts in off-road mode.
After verifying that our batteries were working to specification, charging and discharging, it was time to button them up for good. So we took them apart one last time, double-checked everything, added our insulation back on and padding, and put them back in the original battery metal boxes that they came in. This was a tedious process, just like everything, and it was worth it. It was like putting a big puzzle piece together after taking it all apart. Once that was done, it was time to repair the chain tensioner for the motor. So before, they just had an L-shaped aluminum bracket welded on poorly, and that broke right off like a toothpick. So I took a triangle piece of Series 10 extrusion fastening bracket, and I went ahead and epoxied that on with JB Weld epoxy. The result was it was stronger, better, and stopped the chain skipping motion because the chain was perfectly tensioned on the bike. So one more success in this rebuild process. Let's conclude. So I started this project with a bike that had a dead battery and wasn't really functional at all. I ordered 312 batteries, took apart the old battery, put the new battery in, 13 parallels, 7 series, or 7S 13P as they like to say. Once that was done, I got the BMS built and dialed in, and everything else worked like a charm after I replaced the chain tensioner on the motor side with a more stronger triangle shaped bracket and replaced all 3 tires and tubes with brand new tires and tubes. This is a really neat idea and contraption. I think everybody should experience the wonderful world of recumbent biking, particularly those folks who aren't able to bike in any other way. In any case, that's all I got for you today. Thank you for watching. If you like this video, please subscribe and like and comment. We'll see you around.